Okay, it's equaling. Let me close my can. Share screen. Nice. Can you see the screen? The question?
Yes, sir.
Okay. We have a pipe system given, and these are the initial discharges. These are gases, of course. K values are also given for each pipe. Okay. I forgot to put the unit, so I think I never used unit in my equations. Okay, so it doesn't matter. You can call them liters per second or meter cube per second. It doesn't matter. I forgot to put the unit. So the question wants us to determine the discharge in each pipe. When we have a pipe system like this, like there are 5 pipes, and we don't know what is the discharge inside of them, we will apply the Hardy-Cross method. What is Hardy-Cross method? We will divide this pipe system into 2 loops. We can take this first triangle as our first loop and investigate. Then after investigating the first loop, we will check our second loop, which is this upper triangle. And then we will add our modifications. I mean, we will modify our discharges, these initial values, if it is necessary, of course, after the investigation of first loop and second loop. And if it is needed, we will carry another iteration, and it will continue like that after we reach a point which is satisfactory for our Hardy-Cross method. So how do we start for an Hardy-Cross method? As I said, we will take this first loop, which is A, D, and B triangle. So in the first column, you should write the names of the pipes, like pipe AD, pipe DB, and pipe BA. Okay. Then you should define your positive direction. I put it here. So the clockwise direction is our positive direction. So what that means is, if our flow is following the clockwise direction, we will accept this as a positive. If it is against it, we will take it as minus or negative, you can say. So for the first loop, we will start with the pipe AD. Okay, before that, we have K values. The K values are given by the question. For pipe AD, for pipe DB is 1, and for pipe AB, it is 2. So now we come to flow rates. Let's check for pipe AD. So clockwise is like this, okay? So if you can look at here, it follows the clockwise direction because it's going up. So we will take this 30 as positive. So next pipe is pipe DB. When you look at here, it is against, because the clockwise direction is going down, but this one is going up. So it is against the clockwise direction. So we will take it as minus 10. And for the pipe BA, again, check the direction. Again, it is going against the clockwise direction. So we will take this as negative as well. So once you write this K value and discharge values, you have 2 things to calculate for the Hardy-Cross method. The first one, you need to calculate this K times Q times the absolute Q. And the second thing is 2 times K times the absolute discharge. So for pipe AD, for example, we have K as 4. For Q, we have 30, and absolute Q will be 30 again. So it means 4 times 30 times 30 will be equal to 3600. And let me show you for a negative example. For example, for pipe BA, K is 2 discharges, negative minus, the absolute of this discharge will be positive 60. So 2 times negative 60 times positive 60 will be equal to minus 7,200. So this column is calculated like that. The second one, I mean the last one actually. So what do we do here? We have these 2, this is constant, 2 times the K value for the specific pipe. For pipe AD, it is 4. So 2 times 4 times the absolute of discharge. So 2 times 4 times 30 will be 240. For this one, 2 times 1 times plus 10 because it's the absolute value. So we will have positive 20. So you will do this calculation as well. So once you fill this small table, you will sum these 3 values and these 3 values. If you have more pipes, you will have to carry these calculations for all of them in your loop and you will sum them. So at the end, for K discharge times absolute discharge, the summation of them is minus 3,700, and for this column, it is 500. Once you calculate these two, you need to get this delta Q value, delta discharge. The formula for this delta discharge is given as minus total KQ, absolute Q, divided by total 2KQ, absolute Q, I mean. So what are our values for this one? We have minus 3,700, and for this one, we had 500. You put them here, this minus will cancel each other. We will left with positive 7.3. It's absolute, it might come negative as well. So since it is absolute, its absolute value is more than 1, yes, it's more than 1, we will continue. So what that means, for the first loop, we will need another iteration. We know that, but before we continue, we will continue with the second loop, of course. But before we continue with the second loop, we need to modify our pipe discharges according to this delta Q value. So how are you going to do it? You will directly add this value into your initial discharge values. So for example, for pipe AD, we had positive 30, right? So when you add this 7.4, we will have 37.4. It could be liters or meters per second. As I said, again, I forget to write the units. So I draw these arrows. You might wonder why, because for this one and for this one, it doesn't actually matter that much, but for this shared pipe, the direction of a flow might be changing after the modification. This is why I like to draw these arrows to remind myself, because for the second loop, we will use this one, and if the direction changes, I'd like to remind myself that the direction is changed. So let's continue with this pipe DB. We had 10, but it was against the clockwise direction, so it was negative 10. So you bring this 7.4 and directly add the minus 10 to end up as negative 2.6. So for the first loop, negative means it is against the clockwise direction. So it is still going this left top corner. Okay, so it's still going like this upward direction. So I draw it like this. And lastly, for pipe AB, we had minus 60 plus 7.4. We have there is a minus sign here. You might not see it. You can see it's my mistake, writing mistake. So there is a minus there. It will be negative 52.6. And since it is negative, it is still going the right direction. So we come to the second loop, which was DC, CB, and BA. For the first one, it is following the clockwise direction. So this is positive 20. The second pipe, it is against the clockwise direction. So it is negative 20. And for this one, it was going upwards with 2.6. So it is following the clockwise direction. It is positive 2.6. So you can see the difference. For the first loop, it was against the clockwise direction. So it was negative 2.6, but this time it follows the clockwise direction. So it is positive 2.6. And these are the K values. These are directly taken from the image given by the question. Again, you need to calculate K, Q times absolute Q, and 2 K times absolute Q. For the pipe DC, 2 times 20 times 2800. For pipe CB is minus 400 because 1 times minus 20 times plus 20. And for this one, it's 6.76. And you'll sum them, you'll get 406.76. For the last column, 2K absolute Q, 80, 40, and 5.2 after you carry these calculations. Again, you sum it, these two, these three, and you get 125.2. Again, we need to calculate this delta discharge value. How we were doing that, we were putting negative firstly, then you will divide this one with this one. So once you do this calculation, you get negative 3.25. So what these tell us? It tells us that its absolute value, which is positive 3.25, is larger than 1. So we will need another iteration for second loop as well. But as we did in the first loop, first of all, we need to modify our pipe discharges according to this delta Q value. So for the pipe DC, we had positive 20, right? So you will add this one, I did it here. We will have positive 16.75. For pipe CB, we had negative 20. You will add this one, it will end up as negative 23.25, which means pipe CB, this one, which means it is still going upwards. And for this shared pipe, pipe BD, we had plus 2.6 for second loop. Once you add this negative 3.25, we will have this time negative 0.65. Okay, the sign of the discharge changed from positive to negative. What do we need to do? We need to check the direction because positive means it was going upwards like this. So if it is negative now, it should be going downwards like this. It should be against the clockwise. So the direction changed from upwards to downwards, like I draw here. Okay, now we need to do starting doing the second iteration for the first loop. What we had after the modification for the first loop pipes, we had positive 37.4 for pipe AD. This pipe DB, it's shared pipe, coming from the modification after the second loop. What we had 0.65 and it was going like this. We decided the direction after modification. It is going like this. So if it is going like this, for the first loop, it is positive because it follows the clockwise direction, okay? So it is positive 0.65. And lastly, we had this minus 62.6 coming from the first iteration for the first loop. So again, same procedure. Calculate these ones and calculate these values. I did them here. At the end, sum them, and divide the negative of this value with this one. And I did it here. I increased my pace a bit here because like we are repeating the same procedures. If I'm too fast or you don't understand anything, you can stop me and tell me. So we will divide this one with this one, but of course don't forget the negative sign. And this time, for the first time, we got something less than 1. It's absolute value less than 1. So if this delta Q value is less than 1, that means you don't need to perform any modification. So this was last iteration for our first loop because we get delta Q value less than 1. We can stop and we can accept these discharge values for uh, as our final discharge values for first loop pipes. But the only difference with one exception, I can say, for this pipe DB, because it is shared pipe, we cannot accept its value as final discharge because we need to check for second loop as well. But for pipe AD and for pipe PA, we can say these two will be their final discharge values. So let's continue with the second loop. What did we have after the first iteration of the second loop? For pipe DC, we had positive 16.75. I put it here. For pipe CB, we had negative 23.25. I put it here. And for pipe BD, since we didn't do any modification here, pipe BD didn't change. It was positive 0.65, or you can for first loop, or you can say it was negative 0.65 for the second loop. For the second loop, negative means it was going this way, so it is still going that way, and it is negative 0.65. So you'll calculate these values again, sum them. You'll calculate these values and sum them, and you will calculate delta discharge, which is negative total K absolute Q divided by the 2KQ, and you will get this final delta discharge value. Again, its absolute is less than 1, so that means we don't need any iteration for second loop as well, and we can accept these numbers as their final discharge values. So what will be our final discharges? For pipe AD, we have 37.4, positive 37.4. So for the first loop, positive means it is going upward direction. For the pipe DB, we had, since we didn't change it after the iterations, it's still going this way, downwards, and it was 0.65. It is positive for the first loop, but negative for the second loop. And for pipe AB, we had negative 52.6. So what is negative means? It is against clockwise direction, so it is going right to the right side, and 52.6. And for pipe DC, we had positive 16.75. Clockwise direction, it's going to the right side. For pipe CB, we had negative 23.25. To get negative, it should go upwards to go against the clockwise direction. And lastly, we already put it, but check it from this second loop value. So it should be negative 0.65. And as you can see, it's 0.65 and it's against the clockwise direction. So it is negative. So questions. Ask me your questions now, if you have any.
Hocam, I don't understand how we can know the positive or negative sign in case of looking the sign of the arrows.
Sign of the what?
I mean, how can we understand negative or positive signs to look at our errors?
Errors, you mean these delta Q values?
No, in the drawing.
Errors. I'm understanding as
error.
errors. Okay, my bad. Okay, so let me show you from here. This is given us, okay, as an initial discharge values by the question. These are assumptions. The question wants us to decide the real numbers. Okay, so you come here, the direction will decided like this. For you divide, this is a rectangle or square, you can say. You divide into two triangle sections, okay? This first triangle is our first loop, and second triangle is our second loop, okay? So after you divide them, you need to decide the signs of these discharge values. How you can do it? Clockwise direction in this method, the cross method, the clockwise direction goes like this. If you can see my mouse arrow, please follow it. Clockwise direction means like a clock. It starts from here. Assume this is 12. It goes down like this, right? Comes to 3, comes to 6, comes to 9, and comes to 12 again. So this direction, this move will define your positive direction. If these arrows shows this clockwise direction, you will accept it as positive. If it is against them, you will accept them as negative. So let's check.
I understand, hocam.
You
Yeah.
understood?
Yes.
Okay. Any other question? Okay, then I guess you all understood this one, I hope, because you have an exam tomorrow. So I'll stop here for this question.